I am continuing to work through this 2015 AP Physics 1 free response question practice test. So just in case you want to see the solutions to the other questions, I do have a playlist. I'll link that down below, and you can see the other ones in there. And I haven't worked this out beforehand, so I'm kind of coming at it fresh. So let's just see what happens. Okay, so I've got a picture right there. 7 points, suggested time 13 minutes, and I have not been along with these times, just so you know. 2 identical spheres are released from a device at a time t equals 0 from the same height h. Okay, this is a classic, looks like the classic physics experiment where you drop a ball and shoot a ball horizontally. Sphere A has no initial velocity and falls straight down. B is given an initial horizontal velocity of magnitude v0. I'm just going to go ahead and put that right there. v0, how about that? Okay. And travels horizontal distance d before it reaches the ground. The spheres reach the ground at the same time tf, even though sphere B has more distance to cover. Air resistance is negligible. Okay. The dots represent spheres A and B. Draw a free body diagram showing and labeling the forces exerted on the sphere at time halfway. Okay, well, that's pretty easy. So if you're right there and you're right there, that's not necessarily halfway. Half time, right? Half time would be actually a little bit higher because they're speeding up. But there's nothing in contact with the ball. And if there's nothing in contact, then there's only one long-range force on that, and that'd be the gravitational force. Now, 2 identical spheres, they have the identical mass, so they have the same gravitational force. So I'll just put this mg, same thing, mg. Now, a lot of people would say, oh, not a lot of people, but I do see students, especially introductory physics students, saying this one has some force pushing it to the side. And it had a force pushing it to the side to get it to move. But once it leaves, there is no sideways force. There's no force of the motion. But that's a real common thing to do. That's a pretty easy question. I think that's, oh, and label the forces. Okay, I think that's good. Okay, so then moving on to part B. On the axis below, sketch and label a graph of the horizontal component of the velocity of sphere A and of sphere B as a function of time. Horizontal velocity. Well, that's kind of boring. So sphere A goes straight down, its velocity is 0. It starts at 0 and ends at 0. So A and B. So it would look like this. That seems silly. I don't know why. And then B has some velocity v0 and look like this. v0. This is A, B. And that just seems like a silly question. I feel like there's a trick and I'm missing something. On the axis below, sketch and label the graph of the horizontal component of the velocity. And so in this case, the velocity of B is constant because there's no force in the horizontal direction to change its velocity. So that's that. Okay, that's that. In a clear, coherent paragraph length response, which I'm not going to write, explain why the sphere reaches the ground at the same time, even though they are different distances. Okay, so I think the key thing here is for projectile motion, you can break this into X motion and Y motion for any projectile. So for object B, I could write this. The X motion, let's say it starts at, let's put this at X equals 0. That's my origin, just for fun. So my X motion says X final is X initial plus V0t. This is for B. Right? That's the initial velocity in the X direction. And really that's the only the equation that we need. It actually doesn't really matter where it starts. And then the Y motion has a constant acceleration, so I could say Y final is Y initial plus V Y initial t minus 1/2 gt squared. And so in this case, the initial Y velocity is 0, so we just get this. Y equals Y0 minus 1/2 gt squared. That's the vertical motion. Now, if I look at object A, its X motion is the same thing. I use the same equation, but I have X equals X0 plus 0t, because it has 0x velocity. But who cares? And then in the y motion, I have y is y0 plus vy0t minus 1/2 gt squared. And again, this has 0 velocity. So in the y motion, they have the identical y motion equations. They're identical. The x motion is not the same, but the y motion is the same. So if we talk about just looking at this in the y motion, then they hit the ground at the same time because they start at the same position, they end at the same time, they have the same acceleration at the same time. So that's why. Now, you would want to write that out as a paragraph. And I'm not going to do that because no one wants to see me write out a paragraph. But there you go. That's why in a clear, coherent, hopefully paragraph length response, they reach the ground at the same time. Okay, that's question 4. That was actually, I did that in less than 13 minutes. I feel like I'm missing something. There was no. Okay, that's it. Question 4.